Hello, this is the Tweet Team with Jaya, Jenna, and Angel. Have you ever gotten a follow request on social media and wondered, do I know this person? Well, we have the solution for you, the Tweet Team's Degrees of Separation Finder. This is how it works. There are two approaches that we used in order to tackle this issue. One way we measured separation between accounts was by simply calculating the degrees of separation, aka the fewest amounts of edges in a path between the two accounts, in order to indicate their relative distance. Secondly, we took an alternative approach where we assigned weights based on follower to following ratios to the various relationships in the social network in order to find a more sophisticated shortest distance between two users.
We implemented these approaches using a breadth-first search as well as an implementation of Dijkstra's algorithm. We also built two different graph data structures in order to evaluate their respective performance, the first being an edge list and the second an adjacency list.
We tried to make our command line interface as simple and user-friendly as possible. We try to provide the maximum amount of value while minimizing the amount a user has to type, the reason for which most required user inputs are integers. Now, for example, say you are user 14. You are wondering how many accounts user 12 had to go through in order to follow you. In this case, you would want to calculate the degrees of separation between user 12 and yourself. Now watch as we calculate the degrees of separation between user 12 and user 14. And we will be using Dijkstra's algorithm with an adjacency list.
Wow, that was pretty quick. Is there an even faster option?
Yes, there is actually. Utilizing a breadth-first search to find the degrees of separation is even faster, as we cut out the step of having to calculate the relative weights of the edges. So we can do 12 to 14 again, and we can use a BFS with our adjacency list.
The BFS gave a more simple metric of distance, but it executed almost instantly. What about the edge list BFS?
Let's try it out. So we can do edge list BFS with user ID 12 and user ID 14. And we said we were going to do an edge list BFS.
Wow, that was pretty bad. Is there any time that we would want to use this?
We could use the edgeless representation provided that the dataset is small enough. Otherwise, it's going to take a very long time, especially for super large datasets. Thankfully, we do have a smaller, different dataset at hand. We'll use it to try out the second option, which is using Dijkstra's algorithm on the edge list to find the weighted degrees of separation. First, we have to type in the name of the file that contains the graph information, which is small network.txt, and we have to enter the number of vertices, which is 15, and we can do a search from, do you have any ideas of what?
Let's do user 1 to user 13.
All right, let's try it out. And we wanted to do Dijkstra's algorithm with the edge list.
Oh, that time it seemed to work pretty well.
Thank you for taking the time to listen to our pitch. We hope that this will help you next time you're unsure if you should accept that unfamiliar follow request.